Good day, class. This is a lesson on half-angle identities. So please write down the title of this lesson, half-angle identities. Half-angle identities. Now, the materials you need for this lesson, you're going to need your unit circle and your formula sheet, okay? So your materials are unit circle or formula sheet. If you don't have them, bring them out. Formula sheet. All right, so let's write down the learning objective for this lesson. Learning objective. Learning objective. All right, you'll apply, write this down, you will apply the half-angle identities, in evaluating trig expressions, by completing 80% of today's classwork problems, of assigned classwork problems, of assigned boardwork problems. Sorry, boardwork problems. So after the examples I give you, after the I do and you do, I'm going to give you some boardwork problems to try and expect you to complete 80% of the ones I'll grade in order to meet today's learning objective. All right, where is this used in the real world? Write this down. I'm going to write down the real world application so you all can keep up. Okay, so real world application. The real world application of this lesson is in X-ray imaging. X-ray imaging. Okay, X-ray imaging, and mammography technicians use this. Mammography technicians, and then they make anywhere between the average salary of about $62,000 a year. So if you want to help fight cancer, you can go into this field, which is a very good field. So the application is that the diffraction waves, or diffraction of waves used in advanced X-ray devices employs the use of what we're learning today, employs the use of half-angle identities. All right, so write this down. Okay, so let's go ahead and go into the lesson. So before we start working on examples, I'd like to present to you the half-angle identities. Okay, I'm going to clear this page. So the title is going to be half-angle identities. So these are the identities, the half-angle identities. So write them down. The first one for sine. Sine Alpha over 2, this is a half angle. Alpha over 2 equals plus or minus the square root of 1 minus cosine alpha. And then this whole business divided by 2. And then for cosine alpha, it's going to be plus or minus the square root of 1 plus cosine alpha over 2. So there goes your sine, there goes your cosine. And for tan, guess what? You just simply divide these two, and it's going to have tan alpha over 2 equals plus or minus the square root of, sine goes on top, 1 minus cosine alpha, and then the cosine piece goes on the bottom, 1 plus cosine alpha. The 2 and the 2, if you DCF the problem, this 2 goes up and it cancels out with this 2, so we have no denominators. You just have this piece and that piece combined to give you the tan identity. So these are the 3 additional identities you need to know. These are, in fact, the last 3 identities you have to memorize. Alright, so let's try out an example. Example 1. Find the exact value. Find the exact value of sine 105. Sine 105. So remember, sine is a y-coordinate on your unit circle, right? So is 105 on the unit circle? That's the question. Is 105 on the unit circle? So let's take a look at our unit circle and see if 105 is there. So let's see, 19 or 105. Alright, so obviously we can't do this using the unit circle. That's why you need the double angle identity. So what we're going to do here is see how we can plug this into this formula right here. So alpha over 2 is actually what we're given. We're given half of the angle. So write this down. Alpha over 2 is actually 105. So if alpha over 2 is 105, what is alpha? Alpha is going to be twice this, right? So to get what alpha is, what we do is we double both sides. Times this by 2, times that by 2. If you double 105, you get 210 degrees. And guess what? 210 degrees is on the unit circle. Alright? So check this out. We have 210 degrees right here, so it's actually on the unit circle. So now we have a situation where we can actually use a unit circle. So we have this. Alpha is 210. Now let's write out the formula. The formula is sine, because it's a sine problem, alpha over 2 equals plus or minus the square root of 1 minus cosine alpha over 2. Okay? Now we know what alpha is. Alpha is 210, so let's just plug it in. So this is going to become plus or minus the square root of 1 minus cosine. Instead of alpha, I'm going to put in this value, 210, divided by 2. Okay? Now let's evaluate what this is going to be. So is it plus or minus? Where is 105 on the unit circle? What quadrant is 105? 105 is less than 180. 105 is in the second quadrant, right? So let's draw our coordinate system to see if it's plus or minus, so we don't keep writing plus or minus over and over again. So alpha is 105. This is 0, 90, and 105. Sorry, 180. So 105 is here. And we know animal students take calculus, right? So that tells us obviously that our sign is going to be plus. Okay? So from there on, we're going to be using plus. Now, cosine 210. What is the value of cosine 210? You need to go to your unit circle and look for the y-coordinate of 210. So if I go to my unit circle, right here, that goes 210. And remember, this is your cosine, the x-coordinate, this is your sine. So cosine is actually going to be negative root 3 over 2 because that's the x-coordinate of 210. So cosine 210 is going to be negative root 3 over 2. Okay? So negative root 3 over 2 is cosine 210 because of that point we have there. So let's see. So cosine 210 is negative root 3 over 2. Let me write that on the side here so we don't get confused. Cosine 210 is negative root 3 over 2. I just showed that to you. So now we're going to have plus or minus the square root of 1 minus negative root 3 over 2 over 2. Now let's work on this fraction right here. Let's see. So this is going to become, oh, we don't need plus or minus anymore. We can just keep it as plus because we're in second quadrant. So it's just going to be the square root of 1 plus 3 over 2 over 2. We can make this 1 over 1. What is the LCD of 2 and 1? LCD is 2. So times this by 2, times that by 2. And your answer is going to be, it's going to become the square root of, if you have the top, it's going to be 5 over 2. 5 over 2. No, I made a mistake. Let's stop here. Let's go back. I left out the square root, so this is supposed to be the square root here, right there. Okay? So it's going to be 2 plus root 3 over 2. Okay, over 2. And then we can write the denominator as 2 over 1. So we can have a fraction on the top and a fraction on the bottom. So we have a fraction on the top and on the bottom. We're going to DCF this problem, and it's going to become the square root of 2 plus root 3 over 2 times, if you flip this, it's going to be 1 over 2. And then that will give us our final answer, which is, actually not the final answer, the square root of 2 plus root 3 over 4. You may not have a fraction as a radicand as we have here, so we need to split this radical to the top and the bottom. So the top is going to be 2 plus root 3, and the square root of 4 is simply going to be 2. And there goes your answer. The square root of 2 plus root 3 divided by 2. Okay? So that's that. Now I'm going to give you an example to try out, and in about, after the allotted time has elapsed, I will present the solutions to you. Okay? So write this down. Try this. Try this. Example 2. Find the exact value of cosine 5 pi over 8. Okay? Find the exact value of that. Okay, so let's do this. Let's try this example. So I want to find the exact value of cosine 5 pi over 8. So in this case, 5 pi over 8 is radians. I like to work with degrees here, so it's much easier. So I'll times it by 180 over pi. And then when we do the conversion, the pi's cancel out. 4 goes into 8 2 times. 4 goes into 180 45 times. When you multiply it across, you get the angular measure 225 over 2. You can write it like this, or you can write it as 112.5, whichever formulation you like. But I think this form is better. So we have alpha over 2 equals 225 over 2, okay? So if alpha over 2 is 225 over 2, then obviously alpha is equal to 225, right? If you just multiply both sides by 2, the 2's come off, and then you have alpha equals 225. Now 225 is going to be a unit circle for 112.5. It's obviously not there, okay? So now this is what we're going to use to calculate the cosine. So you always have to double whatever angle you're given first to find out what the value is. So let's do the problem. So the formula is as follows. Let me partition my workspace so you don't get confused. The formula is cosine alpha over 2 equals plus or minus the square root of 1 plus cosine alpha over 2. So let's see, is it plus or is it minus? Where is 112.5? 112.5. What quadrant is that on? Let's see. If we draw our coordinate system, this is 0, 90, 180. Oh, it's in the second quadrant. So that tells you that animal students take calculus. S is for only sine and its reciprocal cosecant. So cosine is going to be negative here. So the problem cosine 5 pi over 8. Remember, 5 pi over 8 is the same thing as 112.5 or 225 over 2. So that's going to be negative because of we're in quadrant 2 and only sine and cosecant are positive here. Square root of 1 plus cosine, what is alpha? 225. 225 divided by 2. So I need to evaluate what this is using my unit circle. Remember, cosine is the x-coordinate of the point of the angle on the unit circle. So what is cosine 225? So let's refer back to our unit circle. Our unit circle 225, we're looking at the x-coordinate, right? So the x-coordinate for 225 is this right here. That is the cosine, this is the sine, they're both the same. I just need the cosine, negative root 2 over 2. So that's cosine right there. Okay? So let's use that. So it's going to become negative square root of 1 plus parentheses negative root 2 over 2, because that's what cosine is, divided by 2. Write this as a fraction, and then we're going to find the LCD. Obviously, these are different, so we need to make them both 2's, right? So we times this by 2 top and bottom, so that the denominators are both 2. So we're going to have 2, wrong color. We're going to have the square root of negative the square root of 2 over 2, and then minus times plus is minus root 2 over 2 divided by 2. And then when we resolve the numerator, we're going to have negative the square root of 2 minus root 2 over 2 over 2. Since the numerator is a fraction, we might as well express the denominator as a fraction. So we can DCF and multiply with these. So I put a 1 here. 2 over 1 is the same thing as 1. I have not changed the denominator. I just put it over 1. So let's see, what does that yield? So it's going to give us, if we DCF the problem, multiply by the reciprocal of the denominator, we're going to have negative the square root of 2 minus root 2 over 2 times, if you reciprocate this, 1 over 2. So that's going to give us negative square root of 2 minus root 2 divided by 4. You may not have a square root as a denominator, so we have to simplify that. Root the top, negative root 2 minus root 2, and if you root the denominator, you have 2. So there goes your final answer for the cosine of 5 pi over 8. Okay? Thanks for watching this video. You feel free to go over this over and over again at home if you do not understand it right now. Okay? So right now we're going to start on the boardwork problems.